Okay, so for our third video for week 2 using Microsoft Excel for now t-testing and also normality assessment, because that's important before we do our t-test, we're going to now go to not the histogram aspect of it, but we're going to instead go to the part where we're going to look at assessing whether or not our data are skewed. Also, are our data not fitting that bell curve with regards to some other methods. So we've already kind of started to look at the bar charts or the histogram charts. So the histogram plots we just did in the previous video. So skewness and kurtosis are what we're focusing on now. So we've done the histogram plot. So with skewness and kurtosis, we're looking at some values. And values that are less than 1 suggest that we've got a positive skew. Values that are, or actually I got this turned around here on the bottom there. These are positively skewed values, and then if the skewness values are less than -1, then they're negatively skewed. So we obtain these with descriptive stats. The important thing is to know that we don't want numbers outside of -1 and 1.0. So we'll look at those in a second. So skewness ideally should be between -1 and 1. Alright, so how do we do that with Microsoft Excel? It's pretty easy to do. So we have to go to our data table, and again we've had to create essentially 2 columns. So we've got this group here and then this group here. Alright, now we're going to do our data analysis, or you might have already saved this, but when you do your data analysis you want to make sure that this is got the missing data people removed. So we can do our data analysis. We have to go to Tools, Data Analysis, at least in my version, and then you have to then do your descriptive stats. You do your descriptive stats, the input range here, I'm going to do the age group for here, and I want summary statistics, and I tell it to go. And I didn't click the labels in the first row. Alright, there they are. I'm going to zoom in. Here we go. We've got a kurtosis value of 31, so keep that in mind, and a skewness of 5. So 31 and 5. Now, let's go back over here. We're going to run this again. So we got 31 and 5 in that group. And then that alone is enough to tell you you've got a problem, and a t-test may not be appropriate. So now we're going to go to Tools, Data Analysis, Descriptive Statistics, and this time instead of the column E, we're going to do this column AH, which is my age category for the ever use e-cigarette group. Alright, so I've got the labels in the first row, I run it. So here, what do we got? We had 31 and 5 in that group. Now we had, I think this was 9.88 and 2.86. So closer to like lower numbers, so that's a good thing. But 31 and 5 versus 9.88 and 2.86. These data are less skewed than the others, but what do they mean? What do they mean? So when we look at our actual ideal numbers, remember, skewness should be between -1 and 1, and we had like 31 and 5 for skewness and kurtosis. So you see where you can get those. Alright, so kurtosis deals with the kind of the length of these tails and the shape of the curve with respect to like how spiky it is or how flat it is. So if it's like a box, then that's platykurtic. If it's spiky, that's leptokurtic. So kurtosis, ideally, values should be between -2 and 2. I think the one was like 2.88, but the other one was like 5 maybe for that one. So that was a problem. And over here on skewness, I think one of them was like a 31 or something. Or I can't remember, or -31. It was pretty bad. So you can look at those tables. This one was 9.88 and 2.8. So actually the skewness wasn't so bad as the kurtosis on this, which is really bad on that one. But the kurtosis is awful on this first one, and it's also skewed. So you could see the bar charts from earlier. Now you see these kurtosis and skewness values. You know, that information should tell you that what you're dealing with are data that are skewed. They're not behaving like a normal distribution or a bell curve, and the statistical approach you should be using, you know, may not be the best. So there's ways of looking at this more quickly and easily, just doing a simple normality test. So it's not so easy with Excel. It's very easy with other stat programs. So when we start to use other programs like R, you'll see how easy this is. So this is Stata again, and again we've got our data all in one big group of columns and rows. We don't have to divide them in this program, and I've already done it by this variable here, e-cigarette, but now I can just do what's called the Shapiro-Wilk test by that variable, or let's see, I'll do it this way, by ever use e-cigarette s-wilk age, and it runs the Shapiro-Wilk test, and it shows that for our missing data, they're not normal. Let's see, for group 1 and group 0. So for group 0, here we go. For group 0, the probability, the p-value is really, really, really low, meaning that there's a significant difference from normality with this group with respect to age. And then for this one, also another really, really, really low p-value, again showing a significant departure or difference from that normal curve. So we've got clear evidence from a very easy test that just shows us immediately off the bat that, boom, your data definitely are significantly different from normal. Excel doesn't necessarily allow that to be done very swiftly, but what we can use is we can force it to create a bar chart using whatever bins that we create. It doesn't auto-create those, but then maybe just using those skewness and kurtosis numbers. Now, if you're close to normal, you know, that's okay. You might be able to use a t-test still, but we're going to go ahead and force and use the t-test because that's what we've got with Microsoft Excel, and it's harder to compare those age groups using a non-parametric method with Excel. So we're going to stop this video here, and then we're going to use the t-testing approaches. But before we go further with the t-testing approach, we also have to determine, should we assume equal variance or unequal variance? So is there the same amount of noise in that one group of age for the ever e-cigarette users versus the same amount of noise in the other group? So is the variance equal in those two different groups? If it's not equal, then that's unequal variance. If it is equal, that's equal variance. And there's a t-test for equal variance and a t-test for unequal variance. So we have to know which one we would choose had our data actually behaved normally. So we're still going to go ahead and run the t-test just for your experience. So I'm going to stop this video here and we'll go on further.